Not every radical can be written as a single term. If we're going to avoid approximations, there's times where our radicals are actually going to be involved in a binomial expression. Now, it's really one number. 3 plus 2 times the square root of 5 is one value, but if we were to express it as one term, it would have to be an approximation. We'd have to use an approximation for the square root of 5. So instead, we get something that looks a lot more like our complex number format, where it was a plus bi. Well, in this case, it's a plus b times some radical. 3 plus 2 root 5 and 4 minus 2 root 5 in this case. Now, when we multiply these, we multiply them as if they were binomials, like it's x plus 3 times x plus 2. We distribute. There really isn't a difference in what happens. You multiply the first term in the first binomial times both pieces of the second. You multiply the second term in the first binomial times both pieces in the second. In many cases, those two middle terms will end up being combined. That's only going to be true with radicals when the radical is the same. So looking at what we've got 3 times 4, which is 12. Multiplying the next piece, 3 times negative 2 root 5, we get negative 6 root 5. 2 root 5 times 4 is 8 root 5. And 2 root 5 times negative 2 root 5, we get negative 4, multiplying the two constants in front. And root 5 times root 5 is the square root of 25, or what eventually will be 5. Now, we can combine those two middle terms. Negative 6 root 5 plus 8 root 5. Addition and subtraction are allowed to happen as long as the index and radicand are the same, which we've got here. So we get 2 root 5, bringing down the other terms, evaluating the square root of 25. Now we've got 12 minus 4 times 5, or minus 20. All said and done, negative 8 plus 2 root 5. Remember, the distributive property. You need to remember the pieces. Think of FOIL, first, outers, inners, and lasts, but it's the distributive property that's at work here.